Okay, so now let's do question number 11 and 12. So you have some data over here, like for example something like this. You have basically, you have some marks and number of girls. You have some marks over here, and over here you have the number of girls, and so the marks are 0 to 10, for example, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. And the frequencies related to these are 6, 8, 14, 6, 8, 14, 16, 4, and 2, 16, 4, and 2. And so you want to find the mean deviation about median. Mean deviation about median of this data, which is the same thing as sigma f of I times the absolute value of x of I minus m over sigma f of I, right? So you need to find your median. Now, your sigma f of I, to find the median, you need to find basically the observation that falls exactly between all of your observations, or exactly in the middle, basically. So what that means is that you need to know how many observations you have in total. So sigma f of I is equal to 1428. So you have a 28 there, and then you have 22 there, so that's 40 and 50 observations. The number is even. The number is even. When you have an even number, we said that we would take basically n divided by 2th observation and n divided by 2 plus 1th observation, and then take the average of those two to calculate the median. Now, if n is equal to 50, then that's 25th observation, and that would be basically 26th observation. So 25 would be somewhere over here. This is 14 is equal to 28. So that's 28, that's 14, right? So this, if you calculate the cumulative frequencies of these classes, that would be easier for you to find these terms or these observations. So that's a 6 plus 8 is equal to 14, 14 plus 4 is equal to 28, 28 plus 16 is equal to 14, 1, that's 44, that's 48, and then you have 50. So that means that this observation goes all the way up to 6. These meaning this class. This goes all the way up to the 14th observation, 28th observation, and 44th observation. So 28th observation is over here. That means that 25, 26, 20. So you have basics, but you need to know where to find your 25th observation. So you have 6 observations and 8 observations over here, right? So that means that you have 14 observations in total in here. So your observations are not in these two classes, because you're looking for 25, and this goes only up to 20, this goes only up to 14. And then this one, after 14, you have 14 observations. After these 14 observations up to here, you have another 14 observations in this class alone. So then that means that then basically 14 plus, for example, 11 is equal to, that means that if you go another 11 observations, you would get to 25th, and then 26th of the observation in the same class, and then, and of course this class goes all the way up to 28th observation as well. That means that both of these terms you can find it over here, right? So that means that both of them are somewhere between are in this class. That means that this is your median class. Now we had a formula to calculate the median based on the median class, and the formula was basically we said that the median is equal to basically L plus N divided by 2 minus CF divided by F times H. So what that means is that then your median is equal to L, the lower limit of the median class, 20. N divided by 2 is, well, N divided by 2 is 25. CF is basically the cumulative frequency of the class prior to the median class, which is 14, right? Not this one, but this one, 14. Divided by F, which is the frequency of the median class, which is 14. And you want to multiply the whole thing by H, which is basically your class size 10. So what that means is that, and of course, in order to find the median class, something else that you can do is that you can find N divided by 2, okay, which is in this case, for example, 25. Then you need to be looking for the class whose cumulative frequency is just greater than 25. So for example, 6 and 14 are not greater than 25, but 28 is. So that means that this becomes your median class, right? Now, in order to calculate this, you get basically divide by 2, 5, divide by 2, 7, and then you have 20 plus 25 minus 14 is equal to 11 sevenths. 11 times 5 divided by 7, which is equal to 20 plus 55 sevenths. 55 sevenths is the same thing as, I don't know, 55 divided by 7 is equal to 7 times 7 is equal to 49. So 49 to 55, you have 6. 8 times 7 is equal to 56. 4. And then again, 6 times 7 is equal to 40. 5 times 7 is equal to 35. 5. And you can just keep going, but you would get a 7 point. I take this as 7.85 because over here again I get a 7, so 7.85 is equal to 27.85. 27.85. 27.85. That is your median. So your median M is equal to 27.85. So now that you know your median, you need to calculate other things, meaning that, for example, you need to calculate x of I minus m, but you don't know your x of I, so you need to calculate your class marks. So class marks, of course, this class mark doesn't have anything to do with the word marks here. This marks is basically refers to the marks scored by students in an examination. It has nothing to do with the class marks. Class marks means basically of course you know that in statistics each of these is called a class, and then the class mark is basically the average of the lower limit and the upper limit of a class. So that means that, for example, 10 plus 0 divided by 2, which is equal to 5, is the class mark of this class. Or 10 plus 20 divided by 2 is equal to 30 divided by 2, which is equal to 15, is the class mark of this class, and so on and so forth. So 50, 25, and then you get 35, 45, 55. And these numbers will be representative of basically all the numbers that you could find, for example, in this class or in this class, and so on and so forth. Which basically will serve us as the x of I. So now x of I minus m, the absolute value of x of I minus m, is equal to, so x of I minus m, 5 minus 27.85 is negative 22.85, which I take as 22.85. In the absolute value it becomes positive. 15 minus 27.85, the absolute value of that, you will get negative 12.85, which is equal to 12.85. So I get 12.85. Again, 25 minus 27, that's negative 2.85, which we take as 2.85. 35 minus 27.85 is the same thing as 50 plus 1 is equal to 8.85. 8.85. 45 minus 27.85, so 45 minus 27.85 is the same thing as, well, I take this as, for example, take this as a 3, as a 15, 14, 9 and 10. So that's it. 10 minus 1 is equal to 5, 9, 1, 14, 7, and 1, 17.15. 17.15. Check that with the calculator. So 45 minus 27.85. 17.15. Then the next one is 55. 55 minus 27.85. Since this number has been raised by 10 units, so this will be raised by 10 units, so 27.15. Meaning that 55 minus 27.85 is equal to 27.85. Now I need to calculate f of I times this for the formula. So f of I times the absolute value of x of I minus m. Right? So that's equal to, this is your f of I, of course. So I will do this using a calculator. It's not easy to calculate these, and it would take a long time. So 6 times 22.85 is equal to 137.1. 137.1. Then you have 8 times 12.85. 8 times 12.85 is equal to 102.8. 102.8. Then you have 14 times 2.85. You have 14 times 2.85 is 39.9. Is 39.9. Then you have 16 times 8.85. 16 times 8.85 is 141.6. 141.6. Then you have 4 times 17.15 is 68.6. 68.6. And then you have 2 times 27.15. I'm sorry, 2 times 4 times, let me see, 4 times 17.15 and 2 times 27.15, 54.3. 54.3. If I add all of these numbers together, what I will get is 137.1 plus 102.8 plus 39.9 plus 141.6 141.6 plus 68.6 plus 54.3 is equal to 544.3. So you can say that sigma, basically f of I times the absolute value of x of I minus m is equal to 544.3. So what that means is that then this is m, so this is equal to basically 544.3 divided by 50, which will give you divided by 50, which will give you 10.886, which will give you 10.886. That is the mean deviation about the median, meaning that for example in related to all of these marks, basically about 50% about 50% of these 50 girls, they have had marks. What was the median? 27.85. So about 50% of them had marks above 27.85. About 50% of them had marks below 27.85. And moreover, then most of them basically every girl here was on average, their marks were either basically 10 points or 11 points above, for example, 28, or below, or 10 points below 28, very close to basically in that vicinity. There has been, of course, extremes over here as well. But on average, you can say that on average, every girl's marks were basically either basically 10 units greater than 28, or 10 basically 10 or 11 marks less than 28 marks. So that's basically how we can make sense of this data. Now let me see if my answer is actually correct or not. 10.34. Number 11 is supposed to be 10.34. Well, we got 10.88, which is, there might have been some mistake here, but that's how you calculate this. Otherwise, you could try. I don't know. I don't want to really go back and see what I did wrong. It's not really important in the case of, for example, this calculation. So the next question that we have is calculate the mean deviation about median age for the age distribution of 100 persons given below. So you want to calculate the median deviation about median age. Mean deviation. You want to calculate mean deviation about median age. For the age distribution of distribution of 100 persons given below, or 100 people, or 100, I don't know, just 100 people given below. So the 100 people, that means that basically you've had 100 people, you've calculated, you have basically prepared some data for some distribution about their age, and you want to calculate the mean deviation about the median age. Meaning that you want to calculate the median age and then the mean deviation about that. So now what this basically, how the data that we have is basically the age in years. We have the age in years, and then you have the number of people. Right? So then your classes are 16 to 20, which is 5, 21 to 25, which is 6, 26 to 30, which is 12, 31 to 35, which is 14, 36 to 40, which is 26, 41 to 45, which is 12, 46 to 50, which is 16, and 51 to 55, which is 9. Okay. Now, one thing that, of course, since you want to calculate the median, basically we said that in order to calculate the median is we had a formula for the median, which is equal to basically L plus, for example, L plus n divided by 2 minus CF divided by F times H, right? And this is your class size. But now there is a problem here. Now, as you can see, the class sizes over here are equal, meaning that you go from 16 to 20, 21 to 25, 26 to 30, 31 to 35, 36 to 40, and 41 to 45, 46 to 50, 51 to 54. The class sizes are all equal and equal to 4, right? But the problem is that these classes are not continuous, meaning that you go from 16 to 20, and and then from 21 to 25. So that means that basically normally what you would have is that is 16, for example, to 20, and then 20 to, for example, 24, and 24 to 28, and so on and so forth. Meaning that you would see these two numbers repeated here, you would see these two numbers repeated here, and so on and so forth. And well, since everything in statistics has been done like this, I would think that, for example, what this data means is that, for example, everyone whose age has been 16, 17, 18, 19, and 20 has been basically accommodated into this class. I would think so, because these classes are not continuous. Now what I can do, and then of course you know that when we have these classes written in this way, for example 16 to 20, 20 to 24, for example 24 to 28, and so on and so forth, this class contains all the ages 16, 17, 18, and 19. 20 is not a part of this class. This class would contain 20, 21, 22, 23, but not 24. 24 starts here. Okay? But I'm not really sure about this, but logically I would say that, but again I'm not sure about it. Logically I would say that these classes, what they mean is that, for example, this basically this class over here contains all the ages 16, 17, 18, 19, and also 20. 20 must be also there. Now, in such cases, what you want to do, since everything is in statistics as far as I have seen, is based on this convention that classes have to be continuous. And what that means is that then when you want to draw the histogram of, for example, your data, you would draw it like this, and then you would start from here and then go over all the way up to here, and then something like this, and then something like this, and so on and so forth. You see, these have to be basically continuous, meaning that wherever this class ends, the next class should begin. And then again, there is basically concerns about, for example, the calculation of there is a bunch of things like, for example, the calculation of, for example, the area, for example, under here, and that area actually means something. Okay, in of course we haven't done this in these videos because it didn't seem to be necessary, and it hasn't been so far, but for example, the area under these bars, which is, and this is called, of course, a histogram. The area under these bars is actually does mean something in statistics. And if these classes were not continuous, were not connected together, you would not be able to find the area basically below the bars the way that you normally do it in statistics, because in statistics the way that you do it is that you basically create a polygon, something like that, and then you have to connect basically all these points together, something like this, and it's just something like that. You have to create a polygon and then somehow calculate the area of the polygon in order to calculate all of this shaded area over here. So long story short, because of all of those reasons, these classes have to be continuous, and basically the classes being continuous then basically again fits with every other part in statistics. So you have to make them continuous. Now, the way that you make your classes continuous is that you see over here you have basically you have for example 16 to 20 and 21 to 25, again 26 to 30, and so on and so forth. That means that if you take a look at this on a number line, let's say that this is 16, and then you go 17, 18, 19, and 20, and then you have 21, and then 22, 23, 24, 25, and so on and so forth. So these are basically 4 units. These are again 4 units, and there is a 1 unit gap here. So the way that and every other class is basically is going to be in the same way, has been organized in the exact same way. So what you want to do here is that you have to fill in this gap, and the way that they do it in statistics, you have to see how many units you have in here, which is in this case 1. You divide it by 2, and that's equal to 0.5. So that there you have to add basically 0.5 to the upper limit of this class, which is 20, and then you have to subtract 0.5 units from the lower limit of this class, which is 21. And if you do so, these two will simply join together. So here, basically here you need to add 0.5 units here, and subtract, and here you need to add 0.5 units, and the same thing you have to do for every other class, meaning that to the upper limits you have to add, to the lower limits you have to subtract, and that's how you join all of the classes together. And of course, before you do this, all the classes have to have the same length, otherwise you would get into trouble, right? So what that means is that now I have to rewrite my classes using this new sort of information, and then we will have to work with the new classes. And of course this will kind of basically change the result of all of the calculations that you might do with these classes, because you're actually changing the size of your classes, meaning that you're adding 0.5 units to this end and adding 0.5 units to the other end. So that's adding 1 unit basically to the length of this class, every class. But then again, there is no, I mean, if you don't do this, there is practically no way to begin with the calculation in the first place. So we have to make different sort of compromises so that basically doing things become possible. Otherwise, if you don't make compromises, you cannot do anything really. So that's basically what we need to do. So now let's basically rewrite these classes with this new scheme and see what we get. Okay, so now if I rearrange my classes, I would get basically, suppose that I subtract 0.5 from the lower limit and add 0.5 to the upper limit of each class. That means that I will get, for example, 15.5 to 20.5, right? And now the class size is 20.5 minus 15.5, which is 20.5 minus 15.5, which is 0, and then 5 and 0, so that's a 5. That means that we have actually increased the class size by 1 unit. But basically that's the only way that you can do it. There is no other way. Or over here you can write 20.5 to 25.5. Over here you can write 25.5 to, for example, 30.5. Over here you can write 30.5 to 35.5. Over here you can write 35.5 to 40.5. And then again 40.5 to 45.5. And then 45.5 to basically 50.5. And then 50.5 to 55.5. That's the new classes. These are the ages in years, and basically these are the new classes. Now that your classes are continuous, you can work with them. So now first we need to we basically want to calculate mean deviation about median, meaning that we want to calculate median, which is basically which, let me write it down here. We want to calculate median, which is equal to L plus n divided by minus cumulative frequency over frequency times the class size, which is equal to h. So what I need is the cumulative frequency of these classes, and also I need n divided by 2 to find the median class. Now over here n is basically sigma f of I. This is your f of I. So sigma f of I is equal to 11 plus 12 is equal to 23. 23 plus 14 is equal to 23 plus 14. And then you have 38. You have 38, and then you have 16 plus 9 is equal to 25. Which is equal to 7, 15, 15, 20, 4, 5, 5 plus 5 is equal to 10, that's 100. And we had, of course, 100 people. So n divided by 2 is equal to 50. Now you need to find the median class. You need to first find the cumulative frequency of these classes. So the cumulative frequency over here is 5. 5 plus 6 is equal to 11. 11 plus 12 is equal to 23. 23 plus 14 is equal to 37. 37 plus 26 is equal to 13, 1, 63. 63 plus 12 is equal to 75. 75 plus 16 is equal to 91, and plus 9 is equal to 100. And now you need to go for the class that has the cumulative frequency higher than this, higher than n divided by 2, which is this class over here. This is your median class. So then, based on the median class, I can write median is equal to L, the lower limit of the median class, which is 35.5, plus n divided by 2, which is equal to 50, minus the cumulative frequency of the class prior to the median class, which is basically 37. 37 divided by the frequency of the median class, which is 26, times the class size, which is 5. Not this class size, but this class size, which is 5. So that is equal to 35.5 plus 50 minus 37 is equal to 13. 13 by 20, this is 13. 13 by 26 is equal to 1 to 2. That's 5 to 2, which is equal to 2.5. So that's 2.5. That's 37, 38. 38. So your median is 38. So the median age is equal to 38. Now the next thing that we need to find is the mean deviation about the median. The mean deviation about the median, is the same thing as sigma f of I times the absolute value of x of I minus median m over sigma f of I. So if I calculate x of I minus m, the absolute value of x of I minus m, what I have over here is, now I need to calculate my x of I first. I don't have my x of i's. So I want to calculate my x of I first. So my x of I over here becomes it's basically the class march, right? So this is the class march, which is basically the average of the lower limit and the upper limit of each of these respective classes. So for example, 15 plus 20 is 35, 36, so that's 18. Half of 36 is equal to 18. 20 plus 25 is 45, 46, that's 23. 25 plus 30 is equal to 55, 56. So that's 25, 28. So you see 18 plus 5 is equal to 23. 23 plus 5 is equal to 28. And that's 65, 66, 33. 28 plus 5 is equal to 33. Then you'll get 38. Then you'll get 43. 48 and 53. So these are now your x of i's. And the absolute value of x of I minus m is equal to what? Is equal to, so your x of I is equal to, basically, for example, 18 minus 38. 18 minus 38, so 38 minus 18 is equal to 20, so that's a 20. 23 minus 38. 23 minus 38, the absolute value of that. So you get 38 minus 23, the 5, 15, so that's a 15. Then you have, for example, 28 minus 38, which is equal to basically 10. 20, 15, 10. 33 minus 38 is equal to 5. 38 minus 38 is equal to 0. And you see, when you get to your median class, the difference becomes 0. Now 43 minus 38 is equal to 5. 48 minus 38 is equal to 10. And 53 minus 38 is equal to 15, I suppose. 38 is equal to 5 plus 8 is equal to 13, and then 4, 15. So now I have the absolute value of x of I minus m, and now I can calculate f of I times the absolute value of x of I minus m, which is equal to f of I is basically these numbers, so 5 times 20 is equal to 100, 6 times 15 is equal to 90, 12 times 10 is equal to 120, 14 times 5 is equal to 50, and 20, that's 70, 26, that's a 0, 5 times 2 is equal to 60, 16 times 10 is equal to 160, and 15 times 9 is equal to 90, and 45 is equal to 135. 135. So then sigma f of I times the absolute value of x of I minus m is equal to basically, that's 190 plus 120, 190 plus 120, that's 130, and that's 295. 295. So you get a 5 over here. 11 plus 12 is equal to 23. 23, 2, 3, 4, 5, 7, 735. 735. And so basically then you can calculate this as 735 over sigma f of I, which is equal to 100, is equal to 7.35. So let me first see if my answer is correct, and then 7.35 is correct. So now what this means is that, so this was the age distribution of 100 people, right? So the age distribution of 100 people, and so we have all of these classes, basically 15 to 25, 15.5 to 20.5, all the way up to 50.5 to 55.5. Now the median of our data turned out to be 38. That means that out of all of these 100 people, about 50% of them are above 38 years old, and about 50% of them are below 38 years old. And then basically the and then on average these people are basically either about 8 years, for example. On average, most of these people basically, on average, they are either basically 8 years older than 38 or 8 years basically younger than 38. That means that basically the ages are very close to, relatively very close, are very packed together. Meaning that, as you can see, the frequency over here is not very, you don't see very large numbers over here. So for example, at the extremes you see a 5, or you see a 9, or you see a 6 over here, but most of these large numbers are gathered around the median class. So that means that most of the ages actually fall within these classes that are very close to the median class, and the median, which is 38 years old, is actually some number in the median class. So that means that those ages are very close together, not very far apart. Now, of course, there are these extremes over here. For example, 5 people have been between 16 to 20 years old, or 9 people have been between 51 to 55. But other than that, most of them have been on average, they've been basically about 8 years either older than or younger than about 38 years old. So that's basically what this means. So that was basically exercise 15.1. And in the next video, we will talk about the limitations of the mean deviation. I'll see you in the next video.